in the research that tries to evaluate the effects of climate change across different countries, you typically find that developing countries with high agricultural shares are usually the ones that suffer the most.
Welcome to VoxDev Talks. My name is Tim Phillips. In 1992, Bill Nordhaus kicked off a new era of macro modeling in which our economic activity influences and is influenced by the natural environment in which our economy is embedded. Now, 3 decades later, scientific consensus around climate change is strong, but there's not similar agreement over the appropriate economic policies to deal with it. A new review of macroeconomics and climate shows how far we have come in our modelling of the climate and its effect on the economy and the economy's effect on it. But significantly, it points out where the gaps in our knowledge still are. Gaps that we will need to fill if the low and middle income countries most impacted by climate change are going to have the tools to make good policy. Adrien Bilal of Stanford University is one of the authors of this review. He joins me now. Adrien, welcome to VoxDev Talks.
Hello, Tim.
You have divided your review into 3 areas: loss and damage, mitigation, adaptation. That takes in an enormous amount of research. But what does it mean that you did not consider?
Yes, we tried to be as broad as possible on the economic side. So we tried to include any research that's meaningful for macroeconomic aggregates, models and estimates of climate damages, the role of extreme events, regional disparities, risk. We also covered decarbonization costs, decarbonization strategies, and topics on adaptation. Now, there are a few topics that we would have liked to include but couldn't, mainly for space reasons. So we glossed over the climate science for the sake of space, and because there are already some very good reviews out there that cover the climate science specifically and that are economist-friendly. We also glossed over the very active research in climate finance, which is somewhat relevant for macroeconomics as well. We also glossed over research related to short-run fluctuations only, or research that's more microeconomic in nature.
Do the papers that you were looking at for this review, does it show that the economics profession is giving the topic of climate change and the macroeconomic impact of climate change the attention that it deserves?
Yes. We decided to write this review in large part because there's a lot of interest in environmental economics and climate these days, and it's growing very fast.
Sure.
At the same time, we couldn't really find a high-level overview that would help economists who were new to the field navigate the topic. Now, there are a lot of excellent other reviews out there, but they tend to focus on a specific angle of the question. And by contrast, we wanted something that would be more like a comprehensive guide to help economists get started in this field. That's what we hope we achieved.
So at VoxDev, of course, we're very interested in the impact of policy on low middle-income countries. Of course, this is extremely relevant in this case. And so let's have a look at some of what's in your review. We can't cover it all, but starting with loss and damage. To monetize damages at a country level, there has been a lot of research where macroeconomists have estimated the effect of a rise in temperature on output. What sort of range of estimates are we getting at the moment?
It's wide, but I would say that it's not much wider than the range of estimates that we have on most other macro questions. The first thing that's important is what you mean exactly by temperature. So the classic approach is to look at how a country's output changes when temperature in that country changes. And so there, most of the modern estimates we have imply that a 1 degree Celsius increase in the given country's temperature implies somewhere between a minus 5% output change and plus 5% output change, depending on the country's baseline temperature. So countries that are already hot, like Mali, are likely going to lose, and countries that are originally colder, like Norway, are likely going to gain. So For the world, the average hovers around a 3% loss in output per degree Celsius. Now, it's important to recognize that a country's own temperature is quite different from climate change, because when we think about climate change, we think more about changes in the global mean temperature. And so that's why institutions like the IPCC always talk about global mean temperature. Now, global mean temperature is different from any given country's temperature because, well, it's the global mean.
Yes.
And second, because it includes ocean surface temperatures. And we know from the climate science that the oceans are pretty important for all sorts of climatic phenomena. And so what we've shown with my co-author Diego Cansec in another paper that we discussed in the review is that when you instead evaluate the impact of global mean temperature on output, you find larger effects. And so there the range is larger. It ranges from basically a 0% to a 50% output loss per degree Celsius, depending on the country. And the global mean is also quite a bit larger. It's around 20% loss per degree Celsius. And we show that it's largely due to changes in ocean surface temperatures and to the fact that global mean temperature proxies for all sorts of damaging extreme events, such as extreme wind or droughts.
Clearly, analysing these things at a country level is somewhat artificial when we're thinking about the climate. One of the things that we note at the moment is the increased frequency of severe events, and they are especially destructive in low-income country settings. They do not respect country borders. How can we improve our analysis to take account of these events, to try and estimate their impact? What does this do to the results that we're finding about the loss and damage of climate change?
That's a great point. In these phenomena, these extreme events, say droughts or hurricanes, they occur both at a finer resolution than countries because they hit only specific locations within a country, but they also, as you mentioned, cross borders and affect regions in multiple countries at the same time. So one blunt thing you can do is construct indices that are going to measure a country's average exposure to weather extremes in any given year. That's what we did in our work with Diego, but it's, as you said, it's far from perfect. The alternative is then to use more detailed measures, say of daily temperature, wind speed, and precipitation that are actually available at a pretty granular level, say more or less, the level of something that has the size of counties in the US. And then you can use this much more granular information to assess the impact of these weather extremes on local economic activity if you have good measures of local economic activity at that same resolution. And so there's a fair amount of research that does this in a variety of contexts, including some of my own research.
Macroeconomic research has advanced a lot in recent times, looking at the effects on households, on different regions, different types of people. What can we learn about using the climate science and applying it in this way?
That's a very important point as well. And there are two sides to the argument, I would say. On the one hand, we can learn a lot more. We learn more because we potentially measure the channel that we're interested in much better. So say the effect of a given type of tropical storm on a given region or in a particular group of household. Usually we can look at more behavioral reactions, behavioral changes after that shock hits. Do households move? Do they look for a different job? And so on. So we also get a sense of whether they partly adapt to climate change. Now, on the other hand, when we do that, we face the classic aggregation problem. Once we model and estimate the impact of climatic phenomena at the regional or household group level, eventually we're still interested in adding it all back up to understand what it implies for the macroeconomy. And that aggregation exercise involves a lot of assumptions that are not always easy to test and verify. And we typically rely more on the structure of a particular model there. And that's related to the classic issue that we can't estimate what we like to call the missing intercept when you focus on impacts at the regional level or groups of households. So when we go more granular, we learn much more about mechanisms and possible policy responses to the climate shocks, but we have to rely on more assumptions than when we manage, which is not always possible, but if we do, when we manage to directly estimate the effect on climate change at the country or world level. So we gain on precision on some fronts, but we miss out on others. So that's the trade-off, and that's why both approaches strongly complement each other.
Another fascinating strand of macroeconomic research has been modelling non-market effects. How far have we got in looking at the impact of climate change on things like crime or on political instability?
Non-market effects are very important, but we haven't gotten quite as far there as for the effect of climate change on, say, output. So there's one important exception, which is mortality. So mortality is presumably the most researched non-market effect of climate change. And there's a lot of work there, in large part because we have typically good data on mortality and we also understand how to monetize mortality damages, even though there are a lot of thorny philosophical questions associated with it. For other non-market damages, such as, say, crime and political instability, as you mentioned, so there's a fair amount of work that finds effects there as well. And we understand well enough how to potentially incorporate these phenomena in our modeling frameworks. The fundamental challenge, however, is how to monetize these effects. So we're always interested as economists in putting everything on a common scale. And so we would like to compare the effect of a 1 degree Celsius increase in temperature through productivity declines vis-a-vis through rising crime rates. And it's that second part, the monetizing part, that is harder with crime or political instability. And that's perhaps why there's a bit less work in these areas, but they're important areas to research.
Turning to mitigation, I mean, clearly, if we're going to talk about carbon taxation, we'd have to set aside another 4 or 5 hours on the podcast. There's one aspect of carbon taxation I wanted to ask about. The Trump administration opposes carbon taxation because, and I'm quoting here, what it calls the crippling damages that it would cause to the economy. What does research tell us about this, the impact on output or employment from carbon taxation, the size of those crippling damages?
I would say that the jury is still out on how much the energy transition exactly costs.
Yeah.
There's a fair amount of recent research that finds that carbon pricing actually has pretty modest effect on economic activity, say employment and output, if any effect at all. So what this research does is it typically compares countries that experience different changes in carbon pricing regimes, or it compares different firms that are differentially exposed to changes in carbon prices. Here, we face the same aggregation problem as for damages. My co-author Diego has some very interesting work on carbon pricing in the EU in a separate paper that actually sidesteps the aggregation problem by looking at carbon pricing surprises in the EU ETS market in the time series. And there, interestingly, he finds larger effect of carbon pricing on economic activity, more or less in line with what we know from research on any energy price shocks. So that gives you a fairly wide range of estimates as well. And what we know even less about is how the relocation of workers away from carbon-intensive industries is going to play out. And there, the lessons that we've learned from exposure to Chinese trade, say in the US, have shown that this relocation can be slow and difficult for communities that are heavily exposed and that have few other options. And so I would say we need a lot more work in these areas to figure out what's going to happen.
One area of mitigation particularly important in the development context is carbon leakage for the trade between high-income countries, low-middle-income countries. The carbon leakage that might come from that is undermining the impact of the energy transition. Again, what's the research telling us about this and any policies that might help offset this?
If estimating the effect of the energy transition on employment and output is difficult, estimating the role of leakage is even harder.
Yeah.
Now, trade theory tells us that leakage can be a real problem. But it's also important to remember that a lot of economic activity and the emissions embedded in that economic activity is actually not traded. And so leakage is a little bit less of a problem than the impressions we sometimes get. So let's focus on leakage understood as production of carbon-intensive goods that is shifted to another country, and then the goods, are reimported back with embedded emissions. So 1/4 of emissions is transportation, 1/4 of emissions is power generation, 1/4 of emissions is the industrial processes, and the last quarter is 15% residential and commercial use of energy, and agriculture 10%. So unless everybody in the US can manage to refuel their car in Canada, there's likely not a ton of leakage in transportation. You can make a similar argument for power generation and some of these other items. Now, for agriculture and industry, there you can have more leakage because these goods are indeed traded. And so more or less, you have about 60% of emissions that are shielded from leakage and about 40% of emissions that are agriculture and industry that are more exposed to leakage. Now, we don't have a ton of estimates of leakage so far, unfortunately, but those that we have seem to find relatively modest effects at most once you aggregate to the level of the whole economy. That's an area where we need a lot more research as well. Say you take the risk of leakage as face value, the question is then, as you mentioned, what can we do to reduce that risk? something like the carbon border adjustment mechanism, or CBAM, that the EU is implementing is actually a good option. If you have ambitious domestic decarbonization policies in place, like the EU has, you can price carbon embedded in imports to the same extent as you're pricing carbon domestically. And so that largely nullifies the leakage incentives, because everybody then understands that if they, move production abroad and then re-import goods, they're going to have to pay the same carbon price. In fact, something like the CBAM can even incentivize trade partners to actually put in place their own domestic carbon pricing scheme. Why? Because that way the trading partner collects the revenue from carbon pricing rather than leaving the revenue to the EU. And so we're just starting to see research that evaluates the effectiveness of the CBAM, but so far it seems that it is working. It is limiting leakage.
Mitigation also implies reallocation of labor and capital. You mentioned this a little bit earlier. How can we understand the effect of this? This is always traumatic. How can we understand the effects of this, especially in developing emerging economies?
That's a very important point. And we already talked briefly about it, the labor market effects of the energy transition. There's a little bit of work that looks at what happens when workers are let go after plants become regulated by the Clean Air Act in the US. And what these papers find is that pretty similar effects to what happens when workers lose their jobs in other contexts. But the key question is more whether the Clean Air Act case is representative enough to understand what's going to happen when we engage in a more ambitious decarbonization transition. The key question here is really whether businesses are going to end up cutting back on jobs in that broader context of the energy transition. And there we have some evidence that we've already discussed before, but we certainly wouldn't be heard with by more evidence. On capital reallocation, let me mention that there's a young and growing literature on what we like to call capital vintages that tries to assess whether capital investments are specific to a particular energy mix and what that implies for the energy transition. So how much of the existing capital stock do we need to replace for a successful transition? How much will it cost? That's what this literature is trying to figure out. Now we have good, theoretical models of firms with capital vintages, but the challenge is, again, measurement here, because we typically don't have very good information on whether capital is specific to a particular type of energy. In developed countries and developing countries, typically that information is even scarcer. And so I'm hoping that this literature is going to continue to grow.
Now, it's clear from our conversation that we're not running out of questions to ask anytime soon, but when we get to adaptation, you note in the paper that there has been comparatively less work on adaptation. Why is that?
There are 4 reasons. The first one is that for a long time, we've actually been unsure of the economic effects of climate change. So if you're unsure that there's even an effect at all, you're not going to bother studying whether society is adapting to it. Now we have more evidence of climate impact, and so economists are starting to study adaptation more. The second reason is that we actually don't have a lot of great ways to directly study adaptation. Typically what we do is we look at what happens to an outcome of interest, say output, wages, employment, when there's a climate shock. That tells us what the total effect of the shock is, inclusive of adaptation. Now, to learn about the extent to which there is adaptation, we need more structure. For instance, we can exploit whether the effect of climate change evolves over time as countries or households become richer. And so if we see that the effect of a given tropical storm, of a heat wave, becomes weaker as countries become richer, we're going to infer that potentially, as countries become richer, they're able to adapt more efficiently to extreme heat or storms. But you need a lot more information because you need to trace out the effects of climate change as time goes by. So even though this approach is a bit indirect, it's the most common one that's used in the literature. And it's, for instance, been used successfully to evaluate whether there's adaptation to heat stress for mortality. The third reason is that it may explain why adaptation has been a little bit less studied, is that adaptation might be very different in the 3-degree world than in the past 0 to 1 degree world. If adaptation is mostly about large fixed cost investments, such as, say, levees and dikes, it's very hard to run a cost-benefit analysis on adaptation using past data at large scale. And the fourth reason, which is related to the second one I mentioned before, is that there are few instances in which we can directly observe whether economic agents are taking measures to adapt. You need to observe whether they're actually installing an air conditioning or things like that. Migration is an important exception because there it's relatively easier to observe whether households are responding to climate change by moving between locations. But then again, we then still need to evaluate somehow how migration reduces their exposure to climate shocks. So I hope that we'll see a lot more work on adaptation in the future.
Migration is something that concerns a lot of people working in developing economies greatly. Do we know much? Is it too early to know very much about migration in this context?
So we know some, but we don't know a ton. So despite the headlines that we sometimes see, we actually don't have evidence of massive international migration in response to climate shocks, in particular from low-income countries to high-income countries. If anything, it seems that migration is happening within borders. So there you see stronger responses to climate shocks, but you see less responses across borders. That's what the available evidence so far is telling us. Now, because migration data is often limited, in particular across borders, we actually, still need to learn a lot more about whether migration, might respond at some point to climate shocks, if at all. And we also need to learn a lot more about its effects on the sending and receiving economies. Now, there's a very active field of research that studies the effects of migration on natives, on migrants themselves, that is somewhat independent of climate change. And so, bringing these two fields together seems like a very important strand of research going forward.
One area where potentially we can observe directly the need for adaptation and the effects of adaptation is in agriculture. Development settings have a higher proportion of their economic activity in agriculture. How much of a risk is the failure to adapt? What sort of policies would lead to better adaptation?
Yeah, there are a few ways that countries that are intensive in agriculture can adapt. They can put more protective measures in place, say more irrigation. They can keep the same amount of agriculture in the economy, but change the type of crops they grow, or they can switch away from agriculture altogether and import more food. So let me go through these three options in turn. So protective investments such as irrigation are clearly the easiest to put in place, especially if you have some policy assistance, but their efficacy is also, limited. You can protect your crops to some extent against droughts with irrigation, but it's going to be much harder to protect them against extreme heat. And we know from a large literature on agriculture and climate change that yields starts to drop precipitously with repeated exposure to extreme heat, in particular in developing country contexts. Now, switching crops seems a bit easier, again, perhaps with some policy assistance. Say you train agricultural workers in using different crops that are more resistant to heat. But we don't have a ton of empirical evaluations on the efficacy of those programs. And then again, you still need your soil and your baseline climate to be able to receive these other crops. Switching away from agriculture altogether, that's hard because you typically don't have an obvious other sector where you have comparative advantage that you can use, move economic activity into to finance your food imports. Because if you had that sector, chances are you probably would have a lower agricultural share to begin with. Mm-hmm. So overall, it's actually not that easy to adapt if your agricultural share is high, except through the normal process of development. And the cost of not adapting could be pretty high. In the research that tries to evaluate the effects of climate change across different countries, you typically find that developing countries with high agricultural shares are usually the ones that suffer the most. One thing to add, even though it's not going to change anything for the country level outcomes, you can still mitigate the harm experienced by individual farmers if you have a well-functioning insurance system in place against, say, bad harvests, like you have in some countries. It's not always easy to put in place insurance, in particular in developing country context, but if you let insurance premia adjust correctly, and that's, again, a big if because there's always a lot of pressure, especially for agriculture, to keep these premia low. But if you let these premia adjust, then they will limit, to some extent, the individual harm experienced by those farmers who get hit by climate shocks, while at the same time incentivize the agricultural sector in that country to switch away from crops that are too exposed.
There are so many opportunities for research here. Personally, from your point of view, what are the most promising directions to fill these gaps in our knowledge?
We talked about a few areas, but if I had to summarize, I would say, the labor and capital market effects of the energy transition and adaptation broadly.
We are also seeing much better data, much more granular data now. We are seeing potentially private data as well being made available. Does this help with the research?
Yes, it does. More data, more detailed data is always good. It lets us measure new channels that we couldn't before. Let me give you one example. Say if you can pair block level or address level property value information together with ground level elevation information and with flood maps. That's something that's difficult to do, but is in principle feasible with constellation of private and public data that's out there. That's going to give you a much better sense of the aggregate value at risk from coastal flooding. And so I'm hoping that in the future, we'll see pairings like that, more and more often. That's going to improve our state of knowledge.
When you look at economic textbooks, environmental economics is sort of a supplement. It's something that comes near the back of the macro textbook. Is this changing? Should it change more? Should we be creating more environmental economics standalone courses?
It is changing, and it seems to be changing quite fast. There are a bunch of universities that have well-established programs that specialize in teaching environmental economics. There are a lot of prominent programs. But then you're right that across the broad range of economics department, environmental economics has historically been a little bit less represented than other disciplines. But that's changing rapidly, in large part because there's a lot of demand from students. And so here in the economics department, we now have several courses on offer. In the university, we have a whole sustainability school that's building a whole new program around social sciences and sustainability.
We're coming up on COP30. One of the complaints that we often hear from attendees at COP30 from the Global South is that the political discussion and the economic discussion get separated. A lot of the global policy debate is very polarized. It's very geopolitical at the moment. And it doesn't really have a lot to do with what we've been talking about for the last half hour. How relevant is all of this research if the main actors in the policy debate aren't really taking much notice of the science?
Well, I would say that we just have to keep doing our job, and maybe the science eventually finds a receptive ear. I would say the science is relevant regardless of whether policy actors pick it up immediately or whether it takes a few years. In other disciplines, sometimes it takes 100 years before the science eventually makes it into something practical. For social science, it's part of the normal process to be slowly digested until it is potentially put in practice. Now, in a polarized context, this process might be slower than usual. Really, the only thing that we can do as academic economists is to continue doing our job, which is to produce and explain objective knowledge. How this research is then incorporated into the public debate and into public policy is, I would say, partly beyond us.
Thank you very much for the work that you're doing, Adrian. Thank you for doing this review, which, as you say, is a great introduction for anyone studying economics or economists who really want to know far more about the state of research at the moment. Thanks for talking about it today.
Thank you, Tim.
The paper is called A Guide to Macroeconomics and Climate Change. The authors, Adrian Bilal and James Stock, a name that might be familiar to you if you're studying and doing econometrics. It is NBER Working Paper 33567 if you want to find it that way. This has been a VoxDev Talk. Best way to make sure you don't miss an episode, follow us or subscribe wherever you get your podcasts. We are there. You can find all our past episodes at voxdev.org with articles about the topics that we feature. If you like what you're hearing, please tell someone else about us and also leave us a review. VoxDev Talks is a Talk Normal production. The assistant producer is Megan Bieber and our editor is Andrei Zargarian. Thanks to Oliver Haney and Iman Siddiq at VoxDev.